This video goes over 2.6 geometry proofs. Number 1, we start with two given statements. Then we use the segment addition postulate, which says one segment plus another segment is equal to the larger segment. We replace JK and KL with what they're equal to. That process is called substitution. We simplify 6 plus 10 to get 16, and we're done. Number 2, we have two given statements. From the definition of a midpoint, we know that these two segments are equal to each other since B cuts it into two equal parts. Then we do some substitution and we replace AB with what it's equal to, and then we're done. Number 3, we start with some given information. Then we're going to add either the measure of angle 2 or 105, which are equivalent values, to both sides. We're going to simplify 75 plus 105, and by the definition of supplementary, these two are supplementary. So for number 4, we start off with some given statements and we use the definitions to determine that these angles, either by themselves or collectively, equal 90. And then we use the addition property of equality to add up the same value to both sides and end with the statement we're trying to prove. Number 5 starts with some given information, and we can use the segment addition postulate to say Rj plus Jm is equal to the whole thing. We can substitute for Rj and Rm the values that we know they're equal to. And lastly, we'll subtract 3 from both sides to get Jm equals 5. For number 6, we're given that these rays bisect the angles. Therefore, by the definition of an angle bisector, it cuts those angles into two equal parts, so we know there's those congruencies. And CWD is congruent to DWK, which is congruent to KWN, so that transitive property says CWD is congruent to KWN. For number 7, we start with some given information. We use the definition of what a right angle is to determine these have a measure of 90. Then since 1 and 2 are both equal to 90, they must be equal to each other by the transitive property, or I suppose you could use substitution. And then lastly, the definition of congruent means that if they have the same measure, they're congruent. So for number 8, the first statements are the given ones. Then we can identify that Rs plus St is equal to the larger segment Rt by the segment addition postulate. We can substitute in for Rs and Rt what they're equal to. And after we subtract 8 from both sides, we get St is equal to 26 by the subtraction property of equality. Number 9, we start off with angle C and B are complementary, and the measure of angle C is 50. Those are given. Then we can use the definition of what it means for these angles to be complementary to say that they add up to 90. Then we'll substitute in the known value of the measure of angle A. And after we subtract 50 from both sides, we get what we're trying to prove, that the measure of angle B is 40 degrees by the subtraction property of equality. For number 10, we start off with our given information that angles A and B and C and B are supplementary. By the definition of what it means to be supplementary angles, they add up to 180. Using the transitive property, the sum of the measure of angle A plus B is going to be equal to the sum of the measure of C plus B, since they're both equal to 180, using the transitive property. Then if we subtract the measure of angle B from both sides, we're left with the measure of A is equal to the measure of C. And by the definition of congruence, this means that A is congruent to C. Number 11, we start with MPR as a right angle. That's given. Using the definition of a right angle, we know that its measure is then 90. The angle addition postulate said these two angles that are connected, when you add them up, they equal the larger one. We can substitute for MPR what it's equal to, 90. And by the definition of complementary, MPK and KPR are complementary. In number 12, we're given that GBW is a right angle. So using the definition of a right angle, we know it's 90 degrees. We're also given that the measure of GBT is 35. Next up, by the angle addition postulate, we know that the two smaller angles, when added together, give us the bigger angle. If we substitute our known values, and then we subtract, we get 55 for the measure of TBW.